Everyone.
Good morning.
I hope you had a good week in this rainy goddamn weather. I didn't. So today's topic is I'm going to share some exploration I did. Can you hear me? With CoreText. So before that, I just wanted to do a small, very quick introduction about me. I come from the south of France, nearby the Mediterranean Sea. But somehow I don't like seafood, so it makes my experience in Japan so hard. I traveled in Japan multiple times, kind of did different things before deciding to stay there for a longer experience. Right now I'm working for a company called Eureka. They make products like Pairs and Pairs Engaged. So they try to help people in Japan and Asia find their life partner. So it's a dating matchmaking application. And their goal is, which is I think quite challenging, especially in the context of Japan, is that they try to make dating a social norm in Japan. So I don't know if you noticed, but at least compared to France, Japan has so many marriage matchmaking agencies, which focus on helping people getting married as soon as possible. So there are so many of them in Japan compared to the country. So that's quite interesting. So how did I come up with this CoreText topic? So it's all started with something called animation challenge. So a few months ago in my company, me and my mentor, John, we decided to do this animation challenge. Basically, it's about, we take a look at the application we use every day, whether it's Slack, Twitter, Instagram, etc. And we try to find some cool animation that we can try to recreate in a pair programming of 1 to 2 hours. So do you recognize some of them in the screen? There is maybe the Twitter animation in the middle. What about the others? Someone know? The beer application. There is the Instagram Asana. So I'm talking about it because the top right animation is actually not made with a design tool or prototyping tool, but using Swift and the Cortex framework. So after this pair animation that we did, I wanted to explore more about what we can do using CoreText. Because I think we use custom text drawing everywhere. We all have in our production app this kind of shape, and then we try to fit the text in it, right? Just kidding. We use text drawing almost nowhere, I think. So personally, most of the time I interact with custom text is using the NS attributed strings, which basically, if you don't know, it allows you to customize your text with some properties, whether it's colors, font, etc. But actually, if you dive in a little just with that, it's not related to Cortex. But there are already a few things that you can, a few cool things you can do. So you can indicate the stroke width and the stroke color to draw only the stroke of your text. But also, if you notice, there is both property. There is the foreground color and the stroke color, but the stroke color is dominating. The foreground color is not filled. Does someone know why? Maybe? So that's very interesting. I didn't know until I read the documentation, but if you look at the code at the bottom, I just put a negative value to the stroke width, and it draws both the fill color, the foreground color, and the stroke color. So there are already cool things we can do with basic UIKit APIs. But Apple introduced a long time ago a framework called Cortex, and basically it's a low-level text engine that allow you to create very powerful formatting and layout for your text. So it can be used for custom text layout and formatting, like I showed earlier in this one. It's a very good friend with core graphics frameworks that basically give you the possibility to draw shapes, etc. So some cases where we can use these frameworks about drawing custom layout and formatting are basically, for example, magazine or newspapers app. When you use the newspaper, usually it's separated into column or rectangle, etc. It's specific rectangle and column layout. So that's one of the way maybe you can think about using this CoreText frameworks. Another thing is that if you lack of resource in your team, and maybe there is no designer, for example, and you are assigned to create a text that has some animation and some very custom drawing, then I guess you can use Cortex to figure it out. So today, I wanted to show a few things that we are going to develop together. The first one is this. So we are going to create a simple text and try to make it fit into a circle shape. So we're going to dive into the demo. So to avoid wasting time, I already created the boilerplate. So basically, this is a simple view controller with a UI view. And this UI view is just, we are going to replace it by the first demo we're going to do, which is called shape view. Okay, so let's try to figure out how we can create a text and make it fit into any shape you want. So the first step is to create the text you want to be displayed. So you create a simple text, and maybe you create some customization you want, some fonts, foreground colors, or stroke colors. That's the first step. The second step is, so like if you notice, this is a subclass of UI view. So we are overriding the draw function. So basically, I would recommend you, based on the documentation, to override this draw function if you are going to draw the contents of your view by yourself. So as this is related to low-level API and core graphics, the origin of your frame is different than the UIKit frame coordinate. So when you use UIKit, basically your origin 0, 0 is at the top left of the screen. So in that case, it's located at the bottom left. So the content is flipped. So that's just a little util to kind of flip the text. The first step is to create a shape. So you're really free to draw any shapes you want, from stars to circle, to rectangle, to column, to multiple layout. So in that case, what we do is just we draw a busy path that draws a circle in the middle of the screen. So you got the text, you got the attributes you want to customize, and you got the shape. Now, there is two properties that are important, and that will be the main part of this demo. The first one is called CT frame setter. And what you're going to assign is your string with its property. I'm going to explain a little what it does later. And the second object you need is called a CT frame. So there is a function called CT frame setter create frame that you're going to assign your frame setter and your shape. So basically what this function does is it tries to get your frame setter, which is an object that it's like managing all your frames you're drawing. You get the attributed text, your shape, and you just render the text within that shape. So once you have that, you just have to draw that frame. So if we run, then we have of text that with the text. It's as simple as that. just a summary of what we did to be able to draw a text that fits a shape is we create a text and its attributes. We flipped the frame coordinate because it's related to core graphics and Cortex, and it's a low-level API, and the coordinate system is different. We create the shape we want that will contain the text. And then we create the city framer setter and the city frame that will render that text into that shape. And then we draw them. So Apple in their documentation, they use this, how do you say? This schema. Sorry, I don't know the English name for it. And they try to showcase the main component of it. There are still unknown parts because I'm still discovering how to use that Cortex framework. But we already know some objects we use. We use the city frame setter that manage city frames. And city frames basically are just paragraphs. So like, if you have a text with many, for example, if you have a text like a magazine style, and you have 2 columns, then 1 column is equal to a city frame, which is a paragraph of text. So the city frame setter manages that. And if we want to go deeper, that city frame that contains the text, if this text is has multiple lines, then each line is represented by a city line. Why is it important is that that city line can also be drawn independently. So basically, we can draw each line individually. So this practice we're going to do is a little more complex, but maybe more fun. So what are we going to do? We're going to take someone's name, and we're going to animate the drawing of the stroke, like that. So let's dive in. So I'm going to replace the shape view by the animated text. And then I will go to the animated text view. Okay, so like the first demo, we're going to do that into a few steps. The first step is we get the text we want to draw. Then, that's when it becomes a little more complex. We're going to map this text into something called CG glyph. Is anyone aware of what CG glyph are? Or did anyone already interact with it in this room? No? So, that's maybe the time to show this. So like, I just discovered that recently there is this website called fontdrop.io, where basically you can drop any fonts that you have in your font book application on your Mac, and it gives you many useful information about that specific font, whether it's what it looks like in different text sizes, or more deeper information, such as all the possible Unicode characters that this font contains. And that's where the glyph happens. So when you click at one characters, you can get much more details. And one of them is named index. So basically, each font seems to have something called a table glyph, which repertoire all the Unicode characters available for this font. And this is index as well. So if we take a look at the demo, try to see the documentation of that CG glyph, it just says it's an index of the internal glyph table of the font. So there is this function called ctFontGetGlyph from characters, and basically you're going to give it the text, and it gives you to return you, and it's going to return you an array of indexes that is associated to that table font. So why do we need that? That's where the useful part is that CoreText, there is a useful function called ctFontCreatePath for glyph, and it allows, and it gives you the path for each letter. So for the letter A, it will return you a path, meaning it will return you a list of points and lines so that you're able to draw that letter. So if we resume, we got the text, we map it into an array of CG glyph, that is an array of index. So for example, for the letter A of the text to draw is Aymen, the first letter is A. So for example, the first glyph will be the index number 4 that is associated to that table font. So now we have an array of index, and then we override into, we loop that array of index, and we're going to get the path for each of those glyphs, meaning that we are able to get a path of how to draw that text, that letter. So next step. So there are many ways to draw a shape. The one I'm using in that demo is a very simple shape layer. So the only thing I'm doing basically is I assign the shape of that specific letter to that shape layer. I indicate some properties I want to customize, like the stroke width or the stroke color. In this block of text, in this block of code, it's not related to Cortex. It's basically about aligning each letter nearby each other. It's just for the presentation, so we don't have to care about it. And the last step is animating. So we got our shape layer. What we're going to animate is a property called the stroke end. So CI shape layer has two properties. One is called stroke start, and one is called stroke end. So let's say you have a letter called a letter E. It starts from top and you finish at the bottom. So if you want to draw it, then you will assign the stroke start to 0 and the stroke end to 1, and it will be able to draw the whole path. So in that case, what I'm doing is I'm saying that the start value of the stroke end is 0, meaning that it's not going to be drawn yet. And what I'm animating is that stroke end value. So like little by little, the text will be drawn. So basically this code is, we're going to see it on the demo for more detail, but it's about animating each characters after the previous animation finish. Just a little delay. So if we compile, then we can see that after each letter finished the drawing, the other one starts. So, like earlier, a small summary of what we did to be able to do that. We create our text, we map each character into what is called a glyph, which is an index to the font glyph table of that font. And then we are able to get the CG path for each letter. So we know how to draw each letter. And if we know how to draw each letter, it means we know how to animate as much as we want that letter. If you're interested to look at the code, you can, it's open source, so it's called Cortex Exploration. You can check it out anytime if you want to play with it. And that's all for me. Thank you.
Can you bring back the last slide, please?
Oh, sorry.
And is this presentation up on that URL as well?
No, but I will put it.
Question. Have you looked at TextKit?
Not yet. Maybe it's,
Okay.
it's the next step.
Might be interesting to compare your impressions with TextKit versus Cortex.
Does it do the same thing?
I think TextKit is a higher level API. Cortex is like the lowest kind of foundational level API. I think it's maybe roughly the same on Mac OS and iOS. I'm not sure. I think it's actually basically like a C API, and I think it's like the foundational like typesetting layer that everything else is using. So like UI label is using Cortex under the hood, but TextKit was introduced into maybe iOS 7 or so, and
Okay.
it's like a little bit simpler,
Mm-hmm.
but can do similar types of things. But probably not as much as Cortex is the most powerful one and can do like everything. And
That's interesting.
TextKit is like a simpler one that can do similar types of things sometimes.
That's cool. I will check it out. Did someone already use TextKit?
TextKit.
In this one? I wonder if there is a company who does like newspaper focus application that maybe kind of try to dive in more into like what we can do with text somehow.
This is what publishing companies do, like Adobe or something like that, like desktop publishing, this type of thing. I'm sure they have their own custom layout engines if you're making like a professional piece of software, but it's a very big area actually.
Yeah.
So you showed a lot of like 2D animation examples. Do you think it's possible to do like a 3D one with this? Or maybe it's possible, but it's just very complicated? Or what would be your impression?
That's a good question. To be honest, I don't want to say a wrong answer.
Yeah, okay, yeah.
Like I didn't make it a try to that point of
Okay, yeah.
exploring the 3D. I
Yeah.
feel like at the very bottom.
Okay.
But I'm not sure, like, I wonder if there is another framework more
Yeah.
suitable
Yeah.
for that? Something related to, I don't know, OpenGL or whatever.
Huh.
Did someone already draw text with 3D? In 3D? I guess we don't do that much thing with text.
Yeah. I was thinking like a cool like news program animation where it could like rotate around the globe or something.
All right, yeah. Something like the file that's like the the previous iBook application design had, where every time there is a book
Yeah.
that reached the shell, there is some like file nearby the name of the book.
Yeah, play around.
I mean, I have seen animation in 3D, but not with pure Swift, right? I mean, maybe
Yeah.
using something like, there's a framework from Airbnb, I think,
Oh,
called Lottie,
Lottie.
where
Yeah,
you
yeah,
use
yeah.
like After Effects, I think,
Yeah.
and then you import that into Swift. So that's the only thing.
Yeah, actually, the animation we were trying to do was trying to replicate the Netflix intro,
Oh, yeah.
and we figured out that's crazy maybe in 1 or 2 hours. Like we
Oh.
give up and we just find out that
You also show like not only the stroke, but something like little bubbles that you're going through your name. Is that also in the demo of your?
you mean the Netflix?
Not.
The first.
Yeah, from the first slide.
Yeah, I simplified what we did in the animation challenge. So like,
Just
so actually it's not that much complicated. It's just that in the previous demo we use CA basic animation and we animate the stroke.
Yeah.
So in that demo, what we use is not a CA basic animation; it's a CA emitter. And actually, this you cannot see it, but it's a small heart. This
Oh,
is like
right.
pictures, and it's like CA emitter. So like you give it a path, and it's going to emit those small hearts everywhere through the path.
Oh, that's pretty cool.
So it's just like changing the layer animation.
So in that case, it's the shape is coming from Cortex, but the actual like particles are generated by the particle emitter.
Yeah. So both are good, very good fun.
Do you use Cortex on pairs?
No.
I'm a user, by the way.
Oh, yes.
Yeah.
Did you find your...
iPhone sound. Thank you.
No, unfortunately, yeah, we're not using it. We just like discovering during our animation challenge.
The one thing I've used Cortex for is sometimes I want to find the size of a label, like how it will render on like multiple lines, on a background thread. Because you can't UI kit, you can only use on the main thread. But if you're interested in like trying to do rendering on a background thread, you can actually use Cortex to figure out like what the size of the text would be. Like if you're doing like UI table view cells or something, and you want to like do that, you can actually use Cortex for that.
And you don't need to run the main thread?
Yeah, not on the Cortex should work in a background thread. UI kit will not work on a background thread. So you can't like render your UI label on a background thread, figure out its size and use that. But if you want to calculate the size of strings in that, and you want to do it in the background or like pre-render it or something, and then just use the result of that calculation in the background, or when you're doing stuff like calculating the size of table cells, that's a case where I've used Cortex.
That's cool. So like that's maybe what somehow what's that framework made by Facebook and Pinterest? It's called Texture, right?
Texture, yes.
So like what they do is that auto layout are calculating the auto layout calculation is quite heavy, especially if you have like many cells and many complex layouts. So like what Texture is doing is they are doing the layout calculation in the background. And they calculate all the size, all the frames, and then when it comes to the main thread, they just get that pre-calculated.
Yes, that's right. Same approach as they're using.
That may be useful. Good use case.
Thanks. Any other questions?
Thank you.
Great. Thanks a lot.